What if you could rewind the entire history of the universe? Where would you stop? What would you want to witness? Imagine the power to traverse back through billions of years, witnessing the birth of stars, the formation of galaxies, even the creation of our own home planet. It's a journey that's as captivating as it is complex. Today, we're embarking on an adventure that will take us from the present moment all the way back to the very beginning of time itself. So, buckle up as we embark on this cosmic voyage. Our journey begins nearly 13.8 billion years ago, at a moment we've come to know as the Big Bang. Picture everything that is, was, and will ever be compressed into a singularity, a point of infinite density, unimaginably hot and incredibly small. Then, in less time than it takes you to blink, a colossal explosion occurs. This is not an explosion in space, but rather an explosion of space. An abrupt and rapid expansion that stretched the fabric of the universe itself. In the immediate aftermath of this cosmic detonation, the universe was a hot, dense sea of particles and energy. As it expanded, it cooled, and matter began to coalesce into the atoms that make up everything we see today. From the tiniest grain of sand to the most massive stars, everything has its origin in this singular moment of creation. And just like that, our universe was born. Fast forward a few 100 million years, the universe cooled and stars started to form. Imagine a colossal cosmic soup, a mixture of gas, dust, and dark matter. This soup was not uniform. Some areas were denser than others, and it was in these denser areas that the magic began. Gravity, the invisible hand of the cosmos, started to pull together these denser regions. As they condensed under their own gravity, they formed the first stars. These weren't stars as we know them today. They were massive, burning bright, and short-lived. They burned through their fuel quickly, and in their death throes exploded as supernovae. These dramatic events scattered heavier elements out into the cosmos, seeding the universe with the ingredients necessary for future stars and eventually planets. Now stars are social creatures. They don't like to be alone. So, as more and more stars formed, they began to cluster together, held in place by their mutual gravitational attraction. These clusters of stars were the precursors to galaxies. But how did these clusters evolve into the grand spirals and elliptical shapes we associate with galaxies today? Well, that's a question that still puzzles scientists. It's thought that collisions and mergers between these early clusters played a significant role in shaping galaxies. Over billions of years, these collisions could cause a cluster to flatten out into a disk or become a spherical or elliptical galaxy. The birth of a galaxy is a chaotic and violent process, with stars being flung about and gas clouds colliding. But out of this chaos arises order. Stars settle into orbits around the galaxy's center, and over time, patterns emerge. Spiral arms, bars, rings, these are all features that can form in a galaxy over time. And in these clusters of stars, galaxies like our Milky Way were taking shape. Around 4.6 billion years ago, a cloud of gas and dust in a quiet corner of the Milky Way began to collapse in on itself. Imagine this, a vast swirling nebula, spinning and condensing under the force of gravity. Inside this cosmic whirlpool, a dense hot core ignited, giving birth to our sun, a stellar nursery, if you will. As this newborn star blazed into life, it was surrounded by a swirling disk of leftover gas and dust, the remnants of the nebula from which it was born. It was within this chaotic maelstrom that the seeds of our planets were sown. Picture this. Tiny particles of dust and ice sticking together, gradually forming larger and larger clumps. Over hundreds of thousands of years, these clumps grew into planetesimals, the building blocks of planets. Some of these planetesimals got caught in the sun's gravitational pull and began orbiting it, creating the early outlines of the orbits we see today. Now let's move forward a bit in time. As these planetesimals continued to collide and merge, they formed protoplanets. The heat generated by these collisions and by the decay of radioactive elements caused these protoplanets to melt and differentiate into layers, cores, mantles, and crusts, much like we see in our own Earth today. In the inner solar system, the rocky planets formed: Mercury, Venus, Earth, and Mars. Farther out, where it was cooler, the gas giants Jupiter and Saturn took shape, their massive sizes allowing them to capture the hydrogen and helium gas that the sun was blowing away. Beyond them, the ice giants Uranus and Neptune were born. And so our home system, with its familiar planets, was formed. Isn't it astonishing to think about? the grandeur and complexity of the universe, all beginning with a collapsing cloud of gas and dust. On one of these planets, a miracle of the universe was about to occur. Imagine, if you will, the primordial Earth, a nascent world brimming with potential. Amidst the chaos of volcanic eruptions, seismic shifts, and relentless meteor showers, something incredible began to unfold. Life, in its most primitive form, was stirring. The first life forms were simple, single-celled organisms, floating in the primordial oceans. They were far from the complex creatures we are familiar with today, but they were the building blocks of everything to come. These single-celled pioneers, through the slow, steady march of millions of years, began to evolve. They became more complex, more adaptable, and more diverse. As eons passed, these microscopic life forms grew and diversified. They developed into multicellular organisms, their structures becoming more intricate, their functions more specialized. The ocean teemed with a rich tapestry of life, from tiny plankton to gargantuan sea creatures. But life didn't confine itself to the ocean depths. It ventured onto land, adapting and evolving to fill every available niche. From the smallest insects to the largest dinosaurs, life flourished in an unprecedented explosion of diversity. Plants colonized the land, transforming it from a barren wasteland into a verdant paradise. They pumped out oxygen, changing the very air we breathe and setting the stage for the next phase of life's grand adventure. In time, mammals emerged, and with them, our ancestors. They learned to walk upright, to use tools, to harness fire. They built societies, developed cultures, and dreamed of understanding the universe that birthed them. And so, life on Earth evolved from simple, single-celled organisms into the stunningly complex web of life we see today. It's a story of resilience, adaptation, and the unyielding will to survive. Our planet, once a barren rock, was teeming with life. But what about the future? What lies ahead for our universe? When we gaze into the cosmos, we're not only seeing into the past, but we're also catching a glimpse of the future. The universe, as we know it, is continually expanding. This expansion isn't happening at a snail's pace, but at a speed that's accelerating. Imagine a loaf of raisin bread dough rising in the oven, with each raisin moving away from every other raisin. That's our universe, but on an incomprehensibly larger scale. This expansion leads us to a concept that's as chilling as it is fascinating: the heat death of the universe. As the universe expands, it's also cooling. Given enough time, trillions upon trillions of years from now, it could reach a state of maximum entropy, where all heat and energy is evenly distributed. No stars will shine, no life as we know it could exist. It's a future that's bleak and cold, yet it's one of the most accepted theories about the universe's destiny. But let's not get lost in despair just yet. We're talking about events that are so far in the future, they're almost beyond comprehension. And who knows? Perhaps by then, we would have encountered other life forms, unimaginably different from us, who may have found ways to circumvent these cosmic challenges. The universe is vast, and filled with mysteries that we're only beginning to unravel. From the violent birth of the cosmos in the Big Bang to the formation of galaxies and the emergence of life on Earth, we've come a long way in understanding our place in the grand cosmic narrative. But as for what the future holds, well, that's still largely a mystery. We have theories, we have speculations, but in the end, only time will reveal the rest of the universe's grand story. And isn't that a thrilling thought? The best chapters of the universe's story may still be unwritten, waiting for us to explore and discover. Only time will reveal the rest of the universe's grand story. We've come a long way, from the Big Bang to the mysteries of the future. We've traversed the birth and formation of galaxies, witnessed the inception of our solar system, and marveled at the emergence of life on Earth. We've pondered the potential futures of our vast, complex universe. And through it all, we've reflected on the grandeur of the universe's story. If you enjoyed this cosmic journey, don't forget to like, comment, and share. Join us again as we continue to explore the wonders of the universe.